on top of an SLS rocket. And when that rocket launches, 8.8 million pounds of thrust are going to defeat gravity for a 5.8 million pound vehicle. So they're going to feel vibrations and hear sounds that no humans have ever experienced.
If you want to be an astronaut, that's the thing you've been waiting for your whole life. Riding the elevator up the rocket, climbing in that capsule, very surreal. I often say that the only reason anybody actually gets on a rocket is because it'd be too embarrassing to turn around and run away from the rocket. Once the fire starts coming and the rocket starts vibrating and you lift off, it's a completely different experience.
When you put crew on a rocket, it's no longer a test flight. This one needs to perform and will perform as good or better than the first one did. No doubt about it.
Artemis 2 begins with launch from Kennedy Space Center.
Getting them through that 8.5 minutes to get them to escape Earth will be the first big milestone.
First, you'll do about 2 minutes of flight with the boosters. The boosters will separate, leaving you on just the core stage all the way through about 8 minutes into the mission. At that point, the upper stage will separate from the core stage and perform a perigee raise maneuver to keep you in a stable orbit. The crew's going to be in a high Earth orbit, checkout orbit. So this is a highly elliptical orbit that just takes them up away from the Earth and then back down close to it. From there, Orion backs away and separates from ICPS, preparing us for manual piloting by the crew of the Orion vehicle, imagining that they are approaching and docking with the upper stage of the rocket.
The crew will have their hands on flying it for the first time, and that'll allow them to see, do we have the pulse size correct? Do we need to make the pulse size smaller? Do we have enough thrust? Does it have enough control authority to give us the rates and the movement that we need to in the vehicle when we need it?
We need to really understand how Orion's going to perform in order such that we can dock it on future missions. We're going to fly in formation for a good 2 hours to ensure that we can do the checkouts to really understand the way this vehicle is going to operate. As we do ascent and as we go through our Prox Ops demo, it's going to be a long day for the crew, it's going to be a long day for us on the ground.
Once we convince ourselves that the systems are solid, we will engage the Orion main engine, and that will commit us to what we call translunar injection.
The translunar injection burn is the big burn that puts us on the path to the moon. For that flyby out to the moon, we're doing what we call a free return trajectory. The idea there is that without doing any more major burns, you can just coast, and the gravity of the moon will redirect Orion and bring it back to Earth safely.
Hey, Apollo 13, Houston, you have a go for
We have done a free
systems.
return only one time, and that was during Apollo 13. We have designed deliberately to do a free return on this particular mission because, again, our risk tolerance, our willingness to take risks with the vehicle with the crew on board is much, much lower for a crewed test flight.
The next 3 days are spent in transit, and so the crew has activities to, again, continue to check out the systems on the Orion that we weren't able to get to in the first day. We need to go through checking out the radiation shelter, that all of our stowage is in the right spot. We need to check out the cabin to ensure that we can depress it to be able to dock within HLS in the future. Then we're going to fly around the moon.
You'll fly by the moon at about flight day 5. You'll be between 2,900 and 7,900 nautical miles from the lunar surface.
That'll be the first time we'll have 4 crew members being able to share the experience of seeing the far side of the moon together. They'll be the most separated from Earth than any 4 humans could possibly be at that point.
We're going to turn the spacecraft so that you have the best view of anybody of the moon in 50 years. We want to ensure that we're getting the videos of the moon that all of us back here on Earth want to see, and ensuring that all of our systems work on the far side of the moon as well, the way we expect. Once the crew flies past the moon, they'll begin the 3-day journey home, where they'll again begin to do some checkouts, including trying to take the cabin down to a lower pressure, which is needed for future flights. Finally, as they get closer to Earth, they're going to prepare for re-entry. We have to configure the cockpit, do our final targeting, final burns, get the crew in their suits, get them in their seats, and then they'll get into the re-entry sequence.
The back half of the crew module has the heat shield, which is covered right up until just before what we call entry interface, when you're re-entering the atmosphere, at which point the crew module separates from the service module, puts the heat shield towards the Earth, and then begins its entry.
The way Orion enters the Earth's atmosphere, it's a capsule shape, and when that capsule engages with the atmosphere, it hits at a tremendous speed. The speeds that we're enduring produce temperatures as hot as 5,000 degrees Fahrenheit, which is close to the surface of the sun. The way we protect and absorb that energy is we build a heat shield. That heat shield serves as a function to transfer and absorb that energy so that, ultimately we can come down gently under chutes.
That 19-ish minutes is the most critical of a flight. That heat shield has to work, the guidance has to put them in the right spot, and if we're anywhere as close as we were on Artemis 1, we're going to drop that capsule within a couple miles of the landing ship.
Splashdown.
We're going to land off the coast of San Diego in the Pacific Ocean, and we're going to test out in real space in real time the recovery of crew from the capsule. So all of these are new things that we haven't had to do before in a long time.
They'll be recovered by our recovery forces, and we'll see their smiling faces. That's the mission. That's Artemis 2.
We learned a ton on Artemis 1. A lot of just how the vehicle works and how to fly it, especially from our perspective.
When SLS cleared the tower at Pad B, we put Orion exactly where it needed to be. The upper stage conducted a perfect burn. Orion spent an incredible retrograde orbit around the moon, achieving a distance further than any spacecraft designed to carry humans had ever been. And when it came back to Earth, it performed the first ever skip re-entry of a vehicle.
For Artemis 1, the #1 priority mission objective was a test of the heat shield on Orion for lunar return.
Orion conducted the final major maneuver of its mission, a return trajectory correction burn of its thrusters to further fine-tune its path toward its splashdown site in the Pacific.
One of the biggest learnings we had from Artemis 1 was how the thermal protection system was able to perform during reentry. We looked at the heat shield, and there were little chunks of that char that were missing. And we didn't really understand that, and we thought that wasn't predicted.
What happened is some of the heat shield material started to break off, and that we think could happen a little bit, but you don't want it to happen too much.
Our decision has been made first around safety on the heat shield, as we understand and mitigate the risks that come with spaceflight.
Sometimes in space, delays are agonizing, and slowing down is agonizing, and it's not what we like to do. But from the crew perspective, the thing that we most asked our leadership for after Artemis 1 was root cause of the ablation of the heat shield. We had an independent review team with a lot of outside experts and internal experts to look at this. So we really appreciate the willingness to take the risk to actually slow down and understand root cause, determine the path forward, corrective action for Artemis 2 and Artemis 3, so that when Victor, Christina, Jeremy, and I launch and land after a successful Artemis 2, we will look to Artemis 3 to carry the torch forward and to put humans back on the moon, and that is really our ultimate objective.
Had the crew been on Artemis 1 in the Orion heat shield, they would have been safe. This was certainly an area that we knew we wanted to test out. One reason why, of course, there were no crew on Artemis 1, so we could test out that heat shield. But we wanted to make sure we understood that problem. And we did an enormous number of tests to confirm that under specific conditions, yes, we can fly it safely. But in the future, we want to take this learning and not only apply it to safely flying Artemis 2, but to changing how we design and build the heat shield for the Artemis 3 and beyond. This is what we do. We are ready for it. This is how we work. This is how we learn.
It will be a 10-day journey going 500,000 miles, continuing to test out every bit of Orion, going around the far side of the moon, heading home through the Earth's atmosphere at over 25,000 miles per hour and splashing down in the Pacific.
The crew's going to have a horizon, they have a moon, so I feel pretty good about pressing into this opportunity.
I think NASA's at its best when it has big ideas and bold exploration. That's when the finest comes out of NASA, that's when the finest comes out of America. Their story is made up of the success of this institution that makes this country so proud.
For Orion, success means first we bring the crew home. Second, we demonstrate what we know already is a robust spacecraft that's ready for these Artemis missions.
We want to continue to explore, we want to continue to learn, we want to go beyond, we want to go even further. And through the success of this particular mission of Artemis II will help spur us on for the additional exploration and discoveries that are out there for us to find.
Our destiny is always to go and see what's further and what's next.
It's our generation's opportunity to have our own literal moonshot.
When we focus on one thing and we focus on it together, we can achieve anything.
It's the lesson that we can do more together than we can as individuals. It's a new beginning. It's a rebirth of human exploration.
The question is no longer if we're going to return to the moon or reach Mars. It's a matter of when.
But it starts with one flight, one crew, Artemis II.
We all have batons.